Hey guys, this is Patrick from STH, and welcome to my session at NVIDIA GTC 2022 Fall. In this session, we are going to look at one of the most exciting things that you can possibly imagine, and that is using NVIDIA GPUs with an Arm server. And to do this, we are going to use an Arm server from Gigabyte that uses an Ampere Altra Max processor with 128 cores and NVIDIA A100 GPUs. There's even NVIDIA BlueField-2 DPUs in the system. So in this session, the basic game plan is I'm going to talk a little bit about the high level on why you would want to use an ARM versus an x86 server. There are definitely trends in the server industry that are pointing in this direction. We're also going to take a look at the Gigabyte G242P32, which is the basis of the NVIDIA ARM HPC development platform. And this is really what you want if you want to start developing on an ARM server today with an NVIDIA GPU. After that, I'm going to just show you how easy it is to get started with this, because that is a lot different than it used to be, and it's also different than some of the other NVIDIA kind of lower end options that are in the market, and it's just a totally different experience by using this kind of server platform versus using those lower end platforms. So I want to show you that. And then I'm going to show you how to get resources, for example, like running containers with NVIDIA NGC to be able to start running containers and start using things on the system without having to develop absolutely everything from scratch, because there's a ton of foundational work that's out there, and it's actually not that hard if you want to get started, but I'm just going to get you down that path. We're also going to talk a little bit about the performance, and then what I want to do is just kind of give you a broader perspective on what we're seeing in the market and why this system in particular is so important to start working on. Finally, we're going to end with a little wrap up. With that, let's get started, and let's just do some brief introductions here. So first, I'm Patrick Kennedy. I'm the editor-in-chief and chief analyst at Serve the Home, and we've been covering the server market for years, and we have probably the oldest just dedicated server review website. We do server storage and networking, and we have, just a ton of resources out there on all different types of servers and architectures. I've personally been working with ARM servers ever since the old Cavium ThunderX days, back when it was extraordinarily difficult to even just get Ubuntu running on a server. It was very, very difficult back then, but it is definitely way different today. And I just want to say thank you to Gigabyte for sponsoring this talk, because that's basically how you're going to be able to see this. While you can find our content on the website and on YouTube, this is a GTC session, and so Gigabyte is sponsoring this GTC session. And if you're wondering why would Gigabyte really go and advertise and sponsor a session on ARM servers with NVIDIA GPUs? Well, number one, they actually have the official dev kit from, NVIDIA. This is like the dev solution that we're using. And then the other thing is that just Gigabyte has been really a leader in terms of going out and starting to use and really kind of pathfind with a lot of the ARM server platforms over the years. They've been, for more than 5 years working with different ARM platforms. And so they really have been kind of working on getting different types of ARM servers working in the market and to customers. And so they have a lot of experience with that. And I think that's why they have the dev kit for NVIDIA for this generation. Now, before we get into the actual hardware, I do want to just point out that this is a very different solution than a lot of the other solutions that you see in the market. And the reason that it's very different is because, well, this is a real server. You literally install, and you're going to see this in a bit, we literally will just install Ubuntu and it will start working. You can run it like a normal server. There are a couple little caveats, but your general workflow is just super normal. And to the point that you have things like you have baseboard management controllers. So you have out-of-band management just like you would have on an x86 server. You use the same DDR DIMMs, PCIe cards, all of those types of features that you would use in a normal x86 server. The big difference is really the fact that you're using ARM. And one of the big reasons that these ARM platforms are becoming so popular is because there are a number of applications where ARM CPUs make a lot of sense. And one of them is actually this accelerated platform, because we have these giant NVIDIA A100 GPUs. They have 80 gigabytes of HBM memory on them, and these things are very large GPUs, but they're also offloading a lot of the things that some of the other like x86 CPUs would seek to offload. And for example, if you're doing floating point calculations, well, NVIDIA and ARM's idea is, well, why don't you offload the computations or the floating point computations to the A100s rather than running them on the ARM CPUs? And that means that you can make cores that are optimized for the things that aren't being offloaded. And what that means is that in this server, even though we only have one CPU, that CPU has 128 cores with the Ampere Altra Max. And if you want to see what one of them looks like, it looks like this right here. These are very much the same size as x86 chips, if not a little bit bigger. And the other big reason that you would want an ARM server is really because that's part of NVIDIA's strategy going forward. Now, NVIDIA has already talked about the NVIDIA Grace and Grace Hopper, where they will have an ARM-based CPU, and they will have an ARM-based CPU along with the next generation of GPUs, but that's still a little ways away. So for now, if you want to get started in the development for, servers, data centers, and you actually want to go and try out ARM plus the CUDA-enabled GPUs, well, that's probably, this server is really probably your best bet at this point. And part of NVIDIA's overall strategy is really to use ARM kind of up and down the stack, because ARM is not just for data centers, of course, it's not just for cell phones where it's commonly used, but NVIDIA also has other platforms like this is the Jetson AGX Orin, and this is a ARM processor with an Ampere generation GPU, but it's really a lower power platform designed for robotics and the edge. So if you want an application that you can run in both the data center and at the edge, running ARM and an Ampere generation GPU, that actually is kind of gives you some continuity between something that would be low power that you'd put in a robot or something like that, and also something that you would put in a data center. And that's exactly why this is a huge deal what we're looking at today. With that, let's take a look at the server. So the server that we're looking at today is a Gigabyte G242P32. And this is a 2U server that is really designed for accelerated computing. And in fact, this particular server is really designed for the Ampere Altra and this HPC development platform from NVIDIA. Now at STH, we review a ton of servers, including those from Gigabyte. And this is a platform that Gigabyte has here that is not just for the Ampere Altra. Gigabyte actually has versions of this platform. They're not exactly the same, but they're pretty darn similar. And those are x86 for Intel and AMD. And so the big thing to keep in mind here is that this is an ARM server that is very analogous to its x86 brethren. Now, the G242P32 has 4 bays on the front of it, and these are actually SAS or SATA bays, and in the development platform you actually get a 6 terabyte drive. We didn't get that 6 terabyte drive, so we are just using an SSD in this, but there are different versions I will say that Gigabyte has. They're not necessarily this exact drive configuration. Gigabyte does have a couple other options, so you can look on the website and just go look those up. We also have them on the STH main site if you want to go see some of the other storage options, but really behind that and above it is the GPU area. Now you can see that there are actually labels for 4 GPU spots, but we're only going to be using 2 of these for the A100s in this platform because the official platform only supports 2, and so those will be along the top edge of this platform as we install them. Behind that, we have 4 fans, and then behind the fans, we have this motherboard that's actually kind of cool itself because we have some M.2 slots for boot drives. We also have things like we have a Broadcom SAS 3008 controller, so that's what's providing SAS and SATA to the front storage bays. We can also do things like RAID on that card, like RAID 1 or RAID 0 or something like that, RAID 10. And then the other thing that we have is we have this kind of really interesting area. And what you'll see is that you have the power supplies on the back of this chassis, and then you can actually move the entire power supply assembly up, and below that is, well, that's where the processor and memory are. And we're not going to install this here, but you could put an OCP NIC 2.0 in this server as well. Now, before we get to those CPU and memory and all that kind of stuff, I'm just going to show you the back of the server just so you can see this thing. You're going to see that we have things like our dual 1 gig Ethernet, so those Intel i350 NICs that you have as just kind of your out of band ports. Now, what we don't have in this system because, well, they didn't arrive in time for the photo shoot, is we did not have the 2 NVIDIA DPUs. And the reason for that is because we do have the NVIDIA DPUs, but we just have the full height versions, and these are the E series efficient DPUs as well, but these are the 2 by 100 gig instead of the 1 by 200 gig, and there would be 2 of those that would go in the system. The challenge is though that these are full height and we needed the low profile DPUs for the system. So that was one thing that unfortunately we didn't get in time for the photography, but I just wanted to kind of show you that the DPU is part of the development kit that you would get. And each one of these is actually kind of interesting itself because NVIDIA is using ARM cores even on its DPUs, and this particular one has 8 ARM cores. And so this DPU actually runs all of your things like your network offloads. It can run your network overlays, encryption, all that kind of stuff on this DPU without actually hitting the host CPU. So the NVIDIA Bluefield series, and we'll have Bluefield 3 at some point, is super important to the overall strategy of NVIDIA, and they are in the system. We just didn't get to take photos of of them. So I'm just going to kind of show you one and also just direct you to the STH main site and YouTube channel where we have a ton of content already on DPUs, and we are going to be having more. But the big thing here is that these are not low-end NICs and a low-end processor. These are 200 gigabit per second NICs that are put into the system because, well, you have PCIe Gen 4 and you have the speeds to actually go and push high-speed I/O, not just to the network with DPUs, but you also have high-speed I/O that you can use for things like your NVIDIA A100 GPUs because you need PCIe or would want PCIe Gen 4 by 16 for those. Now, powering this system is an Ampere Altra Max or an Ampere Altra CPU. Now, there are some versions of the system that do have the 80-core Ampere Altra, and we've looked at that on the STH main site, just the Ultra 80-core processor. The company's name is Ampere. It's started by and it's run by a whole bunch of longtime industry execs, and they are making ARM server CPUs. Now, that Ampere Altra processor, you may know it because it's the ARM processor of choice if you're on the Oracle Cloud and then also the Microsoft Azure Cloud, Google's cloud platform as well. So depending on whichever cloud you're in, and there are actually a number international clouds that are using the Ampere Altra as well. So there are a lot of folks that are really using the Ampere Altra as their ARM processor. And so that is what Gigabyte is using in the server. Now, since I was building this myself, instead of using the 80 core ones that we looked at a while ago, I've instead used the Ultra Max because I thought, well, why don't we use the just absolutely crazy versions of this? Because these don't just have 80 cores. The Ultra Max goes up to 128 cores. And these are not low clock cores by any means. These are 3 gigahertz clock cores, so that's a lot of performance. And by the way, this is actually a very scary installation. It's actually a lot harder to install these than the AMD and Intel counterparts, but I've done a couple of them at this point, and I felt okay doing it in the system, and so thank you to Gigabyte for allowing me to do that in their server. Now, in terms of memory, the standard configuration is actually what we're using here, which is having a 0.5 terabyte of memory, so 512 gigabytes, and we're using 8 64 gigabyte DIMMs. Now, each one of these are DDR4 3200 DIMMs, and that's pretty much giving us enough memory to really kind of run pretty much anything that we want in the system. The other important thing, though, is that the Ampere Altra Max is an 8-channel CPU, and what that means is that we have 8-channel memory, although we can run 2 DIMMs per channel. So if we really wanted to, we could actually put 2 64 gig DIMMs in each of these, and that's why we have 16 DIMM slots there, and we could get 1 terabyte of memory. And you can use larger DIMM sizes, like you could use 128. You could use, larger DIMM sizes if you wanted to hit a larger memory capacity, but we do have budgetary restrictions, so we are using 64 gig DIMMs here. And so after we installed the Ampere Altra Max processor, we were able to also install the NVIDIA A100 GPUs, which go in these GPU slots, and these are some of that really new style of GPU slot where they're cabled because PCIe Gen 4 signaling requires, in a lot of cases, cabled access, but that also means that these things are fairly easy just to go service because you can just pop them out, and they're much easier than if you have the old, riser cards or something like that because they are on cables. And so you just basically put these into the slots, you put them into the system, and they're all ready to go. Now, of course, if you purchase this from Gigabyte, you would have this all pre-populated and stuff like that, but Gigabyte sent me the server and some of the stuff and said, hey, why don't you go install this yourself? And so I did it because that's what we do on STH. One other feature, though, that I do want to mention before we get too far is just the power of this system, because the power supplies in the system, they were on that nice kind of really cool lift up thing, but they are 1.6 kilowatt power supplies. However, one of the really cool things that Gigabyte has and did, I think is a really smart thing in this development platform, is that they don't just have a 200 to 240 volt power supply like some vendors would have. They actually have also, they can go down into and run on 120. So if you're in North America and you're on 120, for example, 120 volts, you can actually just go run this on a just kind of standard outlet. I know there are a lot of places like AI startups that, they don't really have 240 volts in the office or something like that. And if you just need to run it on 120, you definitely can. And that is something that we hear a lot of practitioners in both the HPC and also AI space wonder why some systems can't run on just kind of standard outlets. Gigabyte actually thought about this, and you can do it with this system. So as a recap, this Gigabyte G242 P32, well, this thing has 128 ARM cores, and these are ARMv8 cores. We have 2 NVIDIA A100 80 gigabyte GPUs. We also have DPUs, we have some base networking, and we still have more expandability in terms of storage and also PCIe slots. And the server uses so little power that we can actually go run it on a just standard North American 120 volt 15 amp outlet, no problem. So with that, let's start running this thing, and I want to show you what it looks like. So the first thing I just want to cover real fast is the fact that we are doing this via IPMI, and we are using the HTML5 IKVM, because this is a use case that a lot of ARM servers have not been able to complete in the past, and so it is actually a pretty big differentiator for Gigabyte. I can tell you from experience that the old servers from years ago, like if you're in 2016 and you had an ARM server, this would be an almost impossible task to be able to install Ubuntu from an out-of-band management type of thing like this. But here we have an HTML5 IKVM, so we can log in remotely to the system without having to plug anything into it other than network cables. And then we're able to go in and we can go and do things like install Ubuntu, and we can just literally install the Ubuntu downloaded ISO image from which is 22.04.1 LTS, and we can go install that and just run through the normal installer just like you would an x86 server. As you can see, this flow is identical to what you would see on the x86 side, and so that is something that I have to say congratulations to the ARM guys, because that takes a lot of work both on the ARM and the OS folks, but also on the firmware folks and all the platform folks. So this actually may just seem like it's not a big deal, but if you've been using ARM servers or you had used ARM servers in the past, you probably haven't had this experience, and that's why this is great. Now, because we have some limited time, I am skipping it forward on some of just the watching things spin and progress bars. But once you're done, you reboot the system and you are back into Ubuntu and you're ready to start going. So we're going to go log into Ubuntu and we're going to show you some new things that you can do. Now, as we get into the system, one thing that you might have noticed that we just kind of zoomed by during the installation is that the Ubuntu installer is now so advanced and so, I guess, ready to take these ARM systems that not only does it install no problem, but it also asks you if you want to install the latest NVIDIA drivers directly during the installer, right? When that definitely never used to happen. I mean, this is definitely a lot of work by NVIDIA, the Ubuntu folks, the ARM folks. I mean, everybody coming together to make this happen so you can actually use this product out of the box without a whole lot of just searching the internet. So this is absolutely great. Just want to say that you can totally go down that path. The other thing you can do though is you could install the HPC SDK and you can install the HPC tools, and NVIDIA has a very easy guide to go do that, and I would totally suggest starting there. The other things that I think would be important to do is to install Docker, and then also to install NVIDIA Docker, so that way you can actually go and run NVIDIA containers. Now, a lot of the NVIDIA ecosystem runs off of the NVIDIA NGC containers, and if you don't know what NGC is, that's basically NVIDIA's container library. So NVIDIA and its partners maintain containers that have NVIDIA CUDA and NVIDIA accelerated applications in containers, and they're already prepackaged for you, so you don't need to go and figure out how to set things up and get them to be optimized. They already have done that work for you. So personally, I would say that is, especially if you're just starting out and you don't want to spend a lot of time searching on the internet for how to do things, that is exactly what I would tell you to go do, is to go look at NVIDIA NGC. Now, a little trick there is that not all of the applications at this point are for both x86 and ARM. So you could look for things like ARM64 or multi-architecture, and you can look for those tags on the different containers, but there are some that if you go looking through the tags, you will see that they are x86 only. For example, like NVIDIA Morpheus right now is only x86. It does not have an ARM counterpart. But at the same time, I can tell you that compared to like 2 years ago, the amount of things that actually have ARM support on this is just amazing. And so if you want to go run something like TensorFlow will have an ARM version right out of the gate. And so you can start running TensorFlow applications on a ARM architecture with your NVIDIA GPUs, no problem. Just kind of talking about a couple of little things, just using GCC and doing a quick stream run, you're going to see that you can get at least 150, even at a fairly unoptimized, over 150 gigabytes per second of memory bandwidth using Stream Triad. There are different, if you use different compilers and such, you can definitely get that, I think, over 160 or around 160 on the ARM and the Ampere Altra Max chips. So, that is something that you can do, and there are things that you can do with the topology of the chip to actually make that go faster. But still, just in terms of what we have here, in terms of chip memory bandwidth, you do have enough bandwidth because you have 8 channels of DDR4 3200, and you are getting a lot of memory bandwidth to those cores. We ran a couple of applications that we ran back-to-back on x86 servers, which were actually AMD-based servers, and then we ran the exact same GPUs in this system, and we just wanted to kind of of see what the difference was between running on ARM versus running on x86, and this is an AMD architecture. And what we basically found was that we were pretty darn close. It was not necessarily the exact same in all cases, but at the same time, this is definitely very close, and this did not look like this a couple of years ago. There used to be huge gaps between ARM performance and x86 performance, but now what you basically see is that for every one x86 core, which is 2 threads, you're seeing that roughly is equivalent to 2 of these Ampere Altra cores. And so to make that easy to translate, if you have a 64-core, 128-thread x86 processor, right now, current generation, it's about equivalent to this 128-core Ampere Altra Max that we have in this Gigabyte server. Now, NVIDIA has some of its own deep learning benchmarks. I'm just going to show you those to you as well, and they're pretty much about the same ballpark as where we are, and so really a lot of the gap has closed. Now, as I mentioned earlier, the software compatibility is not the exact same, and that is one of the big reasons that we actually have a formal development kit, and that is why Gigabyte is selling a formal development kit with NVIDIA, because, well, frankly, there is still a lot of work to go do. But looking forward on why this is an important technology, well, really, this is the technology that NVIDIA is saying, hey, they're putting a lot of effort on. Now, they're still going to support x86 because there's been a long lineage in terms of how the NVIDIA CUDA whole ecosystem has developed and how NVIDIA has developed. So x86 will still be supported. And so NVIDIA really sees this as not just working in the data center and like this development kit, but all the way down to the edge. I mean, they think of robotics platforms, and that's why we have this, ARM core plus Ampere GPU IP, in the AGX Orin. I mean, that's literally what this Jetson AGX Orin development platform really has in it. And so this is kind of like a scaled down low power version of the giant Ampere Altra Max Gigabyte server with the NVIDIA A100 GPU. So, that's level of scaling's there. And NVIDIA does have lower end offerings as well. And so the idea that NVIDIA has is, hey, we can run ARM because a lot of the things that x86 processors try to accelerate, the NVIDIA GPUs can accelerate faster, right? So they're saying, well, we don't necessarily need that acceleration, so we can go and optimize what our CPU cores look like and design those for massive bandwidth. So from an industry perspective, ARM servers, number one, are happening. Number two, NVIDIA on ARM is most certainly happening. And so if you're in the industry and you're doing software development, I strongly suggest taking a look at getting something like this Gigabyte G242P32 development platform because, well, frankly, this is the way of the future with NVIDIA. And so I just want to wrap this session up by saying thank you to Gigabyte for sponsoring this session, NVIDIA for GTC and the technology. And then also, if you do want to see more on this server, we are going to have follow-up articles on the STH main site as well as the STH YouTube channel. So you can go check us out and find all of those kind of cool resources using this machine there. And as always, thanks for watching and have an awesome day.